Alright, let's go. Number 10. The Laacher See eruption. In 1977, volcanologist Hans Ulrich Schminke of Geomar Kiel published a comprehensive analysis of the Rhine Valley's volcanic history. He had been drilling into the geological record beneath western Germany for years. What he found had been sitting in the sediment layers the entire time, obscured by 13,000 years of ordinary soil accumulation. The Laacher See, a circular lake in the Eifel region, 25 kilometers south of Bonn, was not a natural lake. It was a caldera. The eruption that formed it occurred approximately 12,900 years ago, during the final centuries of the Younger Dryas cold period. Over the course of several weeks, the Laacher See volcano expelled an estimated 6 cubic kilometers of magma, comparable to the 1991 Mount Pinatubo eruption, which temporarily reduced global temperatures by 0.5 degrees Celsius. The ash column reached stratospheric altitudes. The pyroclastic deposits preserved in the stratigraphic record as 3 identifiable units: the lower, middle, and upper Laacher See, tephra, blanket an area extending from northeastern France to Poland. Pumice deposits 40 meters deep surround the lake's modern shoreline. Laacher See tephra, volcanic glass shards, have been recovered from sediment cores in the Baltic Sea, the North Sea, and lake beds across Scandinavia. The eruption collapsed the regional Rhine River system through lahar flows, buried hunter-gatherer settlements across the Rhine Valley under meters of volcanic debris, and discharged enough sulfur dioxide into the stratosphere to trigger a measurable northern hemisphere temperature depression in the years that followed. The eruption deposited ash across approximately 80,000 square kilometers of continental Europe, an area larger than the Czech Republic, at depths sufficient to sterilize agricultural land for decades. But here's where the standard reassurance falls apart. Laacher See is not extinct. The lake sits directly above an active magmatic system. Since at least the 1990s, CO2 has been bubbling continuously from the lake floor, a behavior volcanologists recognize as outgassing from a subsurface magma body. In 2008 and again in 2011, seismic swarms beneath the Eifel volcanic field were recorded by the German Research Center for Geosciences. The German Federal Institute for Geosciences and Natural Resources has classified the Eifel volcanic field as the highest volcanic risk system in Central Europe. The 12,900 BP eruption occurred during a brief, warm period, during which hunter-gatherer populations had expanded across northwestern Europe. The eruption almost certainly destroyed regional populations through pyroclastic surge, lahar inundation along the Rhine, and the multi-year volcanic winter that followed. The Federmesser culture, which occupied the Rhine Valley at the time, disappears from the archaeological record immediately above the Laacher See tephra layer. There is nothing above it for generations. Laacher See sits 37 kilometers from Bonn. The Rhine Valley, one of the most densely populated industrial corridors in Europe, runs directly through its potential pyroclastic zone. Evacuation modeling for a Pinatubo scale event centered on the Eifel has never been formalized into policy. The monitoring exists. The plan does not. Number 9. The Canary Islands mega-tsunami. In 1949, a volcanic eruption on the island of La Palma, in the Canary Islands, split the western flank of the Cumbre Vieja volcano along a 2.5-kilometer fissure. The flank, approximately 500 cubic kilometers of basalt, shifted toward the Atlantic Ocean by 4 meters before the eruption stopped. It has not moved back. In 2001, Dr. Simon Day of University College London and Dr. Stephen Ward of the University of California, Santa Cruz, published a modeling study in Geophysical Research Letters estimating the consequences of a full Cumbre Vieja flank collapse. Their findings were exact. A collapse event would generate an initial wave 650 meters high at the island itself. Within 6 hours, wave trains 15 to 25 meters high would reach the coasts of Morocco, Portugal, and Spain. Within 8 to 9 hours, waves 10 to 25 meters high would strike the eastern seaboard of the United States from Maine to Florida, Miami, New York, Boston, Washington, D.C., all within the inundation zone. At collapse, the Cumbre Vieja flank would displace approximately 500 cubic kilometers of water, 400 times the displacement of the 2004 Indian Ocean tsunami, which killed 227,898 people. The geological record confirms this has already happened. Sediment deposits on the seafloor surrounding the Canary Islands contain multiple debris avalanche layers, indicating at least 6 major flank collapses in the island's volcanic history. Prehistoric boulder deposits found on the Bahamian island of Eleuthera, 100 meters above sea level and 220 kilometers inland from the coast, have been attributed by geologist Robert Hardy and colleagues to exactly this class of Atlantic mega-tsunami. The precursor event, the 1949 fissure, is on record. The flank remains partially destabilized. The 2021 eruption of Cumbre Vieja, which lasted 85 days and produced significant flank deformation, monitored in real time by the Instituto Geográfico Nacional, was watched continuously for exactly this destabilization signature. A full collapse event would strike the Atlantic coastline simultaneously. There is no early warning system capable of providing sufficient evacuation time for the eastern United States. The 2004 Indian Ocean tsunami generated 30-meter waves after propagating 1,500 kilometers. The Atlantic crossing from the Canaries to Miami is 6,000 kilometers. Waves would lose height across that distance. They would not lose enough. The Cumbre Vieja fissure from 1949 remains open. Dr. Day has stated the collapse is a matter of geological certainty. The variable is not whether, it is when. Number 8, the Younger Dryas Cosmic Impact. In 2007, a 26-member research team led by Richard Firestone of Lawrence Berkeley National Laboratory published findings in the Proceedings of the National Academy of Sciences, documenting a thin carbon-rich layer detectable at over 50 archaeological and geological sites across 4 continents. The layer dated consistently to 12,800 years before present. It contained magnetic microspherules, nanodiamonds, iridium anomalies, shocked quartz, and fullerenes, the geochemical fingerprints of a high-temperature cosmic impact or airburst event. They called it the Black Mat. The Younger Dryas impact hypothesis proposes that a fragmenting comet or asteroid, potentially the progenitor body of the Taurid meteor stream, struck multiple locations simultaneously across North America and the North Atlantic at the onset of the Younger Dryas cold period, 12,800 BP. The proposed impact caused massive continental wildfires, deposited platinum group elements in a global stratigraphic layer, contributed to the extinction of 35 genera of North American megafauna, ended the Clovis technological culture, and initiated a 1,300-year cooling event through stratospheric dust loading and meltwater pulse. Platinum anomalies consistent with the hypothesis have been confirmed in Greenland ice cores by Petaev et al. Published in PNAS in 2013, and in South African sediments, Chilean geological sites, and European lake beds. In 2018, the Comet Research Group published findings in the Journal of Geology confirming the platinum signal at 50 sites on 6 continents. The energy released by a continental-scale airburst or multi-point impact capable of triggering a 1,300-year ice age would exceed the combined yield of every nuclear weapon currently deployed on Earth. Here's where the standard dismissal falls apart. The platinum anomaly is real. It has been replicated across 6 continents by independent research teams using independent methodologies. Mainstream geological science has produced no alternative explanation for why platinum concentrations spike globally at precisely 12,800 BP. The debate is not about whether the anomaly exists, it is about what produced it. And the Taurid meteor stream, the proposed source of the fragmenting body, crosses Earth's orbital path twice per year. Its densest debris concentration, which astronomers refer to as the Taurid swarm, returns on an approximately 2,500-year cycle. The last peak was roughly 1,600 years ago. The Clovis culture, the earliest confirmed human technological culture in the Americas, vanishes from the archaeological record immediately above the Black Mat layer. No Clovis sites have been found above it. Whatever population occupied North America in 12,800 BP was reduced to isolated survivor groups who left no continuous cultural record for approximately 1,000 years. NASA's Center for Near-Earth Object Studies currently tracks roughly 2,300 potentially hazardous asteroids. The Taurid swarm's densest debris concentrations are not fully cataloged. The Planetary Defense Infrastructure, the DART mission, the Vera Rubin Observatory's forthcoming survey, is oriented towards single-body threats. A fragmenting object behaves differently. The Chelyabinsk meteor in 2013, an airburst releasing 30 times the energy of the Hiroshima bomb, was not detected before it entered the atmosphere. Number 7, the death of the Green Sahara. In 1933, a Hungarian explorer named Laszlo Almasi was navigating deep into the Libyan desert when he discovered cave paintings at a site he called the Cave of Swimmers. Images of human figures clearly depicted in open water in a region that now receives less than 10 millimeters of rainfall per year. The paintings were at least 6,000 years old. They were not artistic metaphor, they were documentation. Between approximately 11,000 and 4,200 years ago, the Sahara Desert was green. The African humid period, driven by a strengthening of the African monsoon system caused by changes in Earth's orbital configuration, transformed the world's largest desert into a landscape of lakes, rivers, grasslands, and savanna woodland. Lake Mega-Chad, a body of freshwater larger than the entire Caspian Sea, occupied what is now northern Chad, Nigeria, and Cameroon. Hippopotami lived in rivers across what is now central Algeria. Crocodiles inhabited permanent lakes in the Libyan interior. The Nile's flow rate was 3 to 5 times its modern volume. Human populations expanded across the Sahara in densities never seen before or since. Then, at approximately 4,200 years ago, the African monsoon system shifted. The transition from green to desert, documented by Stefan Kropelin of the University of Cologne in sediment cores from the Unyanga Lake system in northern Chad, did not occur gradually. It was a threshold crossing. a tipping point beyond which the monsoon reorganized into a new stable state. Lake Megachad, which once covered 400,000 square kilometers, contracted to its modern remnant, Lake Chad, currently at approximately 1,350 square kilometers and continuing to shrink. Lake Megachad's total volume at peak was approximately 2.5 times the volume of all 5 North American Great Lakes combined. It did not drain slowly. It collapsed. What makes this particularly unsettling isn't the desiccation. It's the mechanism. The monsoon threshold that flipped the Sahara is the same class of atmospheric reorganization, an ITCZ shift, a reorganization of the intertropical convergence zone. That current atmospheric data, analyzed by researchers at NOAA and published in Nature Climate Change in 2019, shows is currently underway in response to hemispheric temperature gradients. The same forcing, the same mechanism, a system approaching the same class of threshold. The collapse of the Green Sahara concentrated previously dispersed populations along the Nile Valley within a few generations. Some climate historians, including Farouk El-Baz of Boston University, have proposed that this migration was the direct demographic catalyst for the emergence of pharaonic Egyptian civilization, that dynastic Egypt was, in effect, a refugee state. If that framing is correct, the death of the Green Sahara did not merely destroy one world. It created another, more famous one. Lake Chad has lost 90% of its surface area since 1963. The Lake Chad Basin currently supports approximately 30 million people. The UN Environment Programme has classified it as one of the world's most acute active water crises. The monsoon threshold that collapsed the Sahara 4,200 years ago did not require industrial forcing. It was triggered by a relatively modest shift in Earth's orbital parameters. The current rate of ITCZ displacement is faster than any equivalent shift in the African humid period record. Number 6. The Black Sea Flood. In 1993, oceanographers William Ryan and Walter Pittman of Columbia University's Lamont Doherty Earth Observatory began analyzing sediment cores from the floor of the Black Sea. At a depth consistent with approximately 7,600 years before present, every core showed the same transition. Freshwater lake organisms below the boundary, saltwater marine organisms above it. The transition was abrupt, not gradual, abrupt. Ryan and Pittman's hypothesis, presented in full in their 1997 book Noah's Flood and supported by their published core analyses, proposed that at approximately 5,600 BC, the Black Sea was a freshwater lake sitting 80 meters below the level of the Mediterranean. A natural earthen sill at the Bosporus, the narrow strait now occupied by Istanbul, had been holding back the weight of the post-glacial Mediterranean for centuries. When the sill failed, saltwater burst through the breach. The peak discharge, modeled by Daniel Garcia Castellanos of the Spanish National Research Council and published in Nature in 2009, was estimated at 30 times the flow rate of the Amazon River. The Black Sea surface rose by as much as 15 centimeters per day at peak inundation. Within months, an estimated 73,000 square kilometers of coastline, inhabited by Neolithic farming communities, was permanently submerged. In 2000, Robert Ballard, conducting deep-sea research with the National Geographic Society, reported discovery of ancient wooden structures at 90 meters depth on the Black Sea floor, potentially representing submerged shoreline settlements. The final breach, at peak discharge, would have generated a waterfall audible from hundreds of kilometers away. The Black Sea's coastline moved inland by approximately 1 kilometer per day. Here's where the modern parallel becomes genuinely disturbing. The Black Sea flood was caused by post-glacial sea level rise, loading a hydrostatic threshold, the accumulating weight of rising ocean water against a vulnerable coastal barrier. The mechanism does not require ice age conditions. It requires sustained sea level elevation against vulnerable coastal geography. The Persian Gulf, which was a habitable river valley 8,000 years ago, was inundated by exactly the same mechanism as global sea levels rose in the post-glacial period. The geography of present coastal cities, built on river deltas, behind barrier islands, on low-lying alluvial plains, is structurally identical to the Black Sea shoreline in 5,600 BC. The populations farming the freshwater Black Sea shores were among the first Neolithic agriculturalists in Europe, part of the cultural complex that spread farming technology from Anatolia into the Balkans and Central Europe. Ryan and Pittman's hypothesis proposes that the displacement event entered cultural memory across multiple civilizations as the archetype for the great flood traditions that appear independently in Mesopotamian, Hebrew, Greek, and Hindu texts. Whether or not that interpretation holds, the population displacement was real. The farmland those people had cultivated for generations is currently 90 meters underwater. IPCCAR-6 projects sea level rise of 0.6 to 1.0 meters by 2100 under moderate emission scenarios, and up to 2 meters under high-end projections. Approximately 630 million people currently live within 10 meters of sea level. The mechanism that flooded the Black Sea does not require a breach event. It requires sustained inundation of low-lying coastal margins. That process is already underway. Number 5. The Storegga submarine landslide. In 1979, Norwegian geologists conducting seafloor surveys for the petroleum industry identified a vast scar on the continental shelf off the coast of Norway, a depression 290 kilometers wide and 800 kilometers long, where the seabed had simply ceased to exist. They called it the Storegga slide. Further investigation established that the scar was not geological erosion over millions of years. It was the aftermath of a single event. The Storegga slide occurred approximately 8,150 years ago. In a single episode, an estimated 3,500 cubic kilometers of sediment, a section of seafloor roughly the size of Iceland, collapsed down the Norwegian continental slope and into the deep ocean. The slide generated a series of mega-tsunamis that struck coastlines across the North Atlantic within hours. In Scotland, deposits of marine sand have been found up to 25 kilometers inland and 6 meters above contemporary sea level, the physical signature of a tsunami inundation event. On the Shetland Islands, marine sediments are found 20 to 25 meters above current sea level. Norwegian coastal sites show inundation deposits consistent with wave heights of 10 to 12 meters at the shoreline. The event struck the inhabited margins of Doggerland, the land bridge connecting Britain to continental Europe, and almost certainly accelerated its final submergence. Sediment cores from the affected region, analyzed by Alistair Dawson at Coventry University, confirm simultaneous deposition of marine debris across all affected coastlines at the same radiocarbon date. The slide was not regional, it was simultaneous across an entire ocean basin. The Storegga slide displaced enough material to bury the entire country of Scotland under 40 meters of sediment. The tsunami it generated struck 6 modern nations at once. But here's where the standard reassurance falls apart. The Norwegian continental margin is not geologically stable, it is a passive margin, a continental slope where sediment has been accumulating continuously for millions of years, loading the same geological structures that failed 8,150 years ago. Geological surveys have identified at least 2 earlier Storegga scale events in the stratigraphic record, the Storegga 2 and Storegga 3 slides, which preceded the main event by thousands of years. Each was triggered when sediment accumulation exceeded a critical loading threshold. The sediment that has accumulated since the 8,150 BP event has now been building for 8,150 years. Researchers at the Norwegian Geotechnical Institute have identified areas of renewed slope instability on the post-slide margins. The mechanism is not dormant, it is recharging. The Storegga slide struck at the moment of maximum human habitation of the North Atlantic coastal zone, the period immediately following the end of the last ice age, when hunter-gatherer communities had spread across every accessible coastline from Norway to Scotland. There is no evidence that any coastal settlement in the direct path of the Storegga tsunami survived the event. They left no record because there was nothing left to make one with. The coastlines struck by the Storegga tsunami now host Bergen, Aberdeen, Edinburgh, Lerwick, Trondheim, and the northern British coast, a combined population of several million people. The North Sea petroleum infrastructure sits within the slide zone. There is currently no early warning system designed to detect submarine landslide-generated tsunamis. The estimated warning time between a Storegga scale collapse and tsunami landfall on the Scottish coast is 1 to 2 hours. Number 4. The 4.2 kiloyear event. In 1993, archaeologist Harvey Weiss of Yale University published a paper in Science, proposing that the sudden collapse of the Akkadian Empire, the world's first empire, which had unified Mesopotamia under Sargon of Akkad beginning around 2334 BC, was not caused by political failure, military defeat, or economic overextension. It was caused by a drought so severe and so prolonged that it rendered 300,000 square kilometers of agricultural land functionally uninhabitable within a period of decades. The 4.2 kiloyear event was a global drought episode lasting approximately 200 years, centered on 2200 BC. It is recorded in proxy data from lake sediments, speleothems, marine cores, and glacial ice across 4 continents. In Mesopotamia, Weiss and his team excavated Tel Leilan in northeastern Syria and found a 300-year occupational gap immediately above a thick deposit of wind-blown silt, an aeolian layer that forms only under conditions of severe desiccation and abandoned agriculture. Contemporary cuneiform tablets describe mass migration, widespread starvation, and the collapse of the empire's northern grain supply. In Egypt, the first intermediate period, a 140-year interval of political fragmentation, social collapse, and documented famine immediately following the Old Kingdom pyramid building era, is now correlated by multiple climatological studies with the same global drought signal. In the Indus Valley, the mature Harappan phase of the Indus Valley civilization, a 5 million person urban culture with sophisticated drainage systems, standardized weights, and trade networks spanning from Afghanistan to the Arabian Sea, abandoned its major cities at precisely 2200 BC and dissolved into dispersed rural communities within a century. 3 civilizations, 3 continents, 0 contact with each other, 1 drought, the combined urban populations of the Akkadian Empire, Old Kingdom Egypt, and mature Harappan civilization at 2200 BC represented the majority of the world's organized city-dwelling humanity. The 4.2 kiloyear event is the only identified geological episode to have simultaneously collapsed three independent civilizations at the same moment. What makes this particularly unsettling isn't the ancient history, it's the atmospheric mechanism. The 4.2 kiloyear event was triggered by a reorganization of the intertropical convergence zone, the atmospheric band that drives monsoon systems across Asia and Africa. Current atmospheric data, published in Nature Climate Change in 2019, shows the ITCZ is currently shifting northward in response to hemispheric temperature differentials. This is not a different mechanism, it is the same mechanism. The same atmospheric reorganization that simultaneously collapsed three independent civilizations is currently being measured in real time. Weiss has estimated that Tel Leilan, the Akkadian administrative center he excavated, went from a population of approximately 25,000 people to zero within a single generation. The site was abandoned and not reoccupied for 300 years. Across the empire, the abandonment of northern Mesopotamia produced a refugee migration southward, documented in contemporary accounts as streams of displaced populations, overwhelming the remaining cities of Sumer. The collapse was not a transition, it was a disappearance. The World Food Programme currently identifies 345 million people as experiencing acute food insecurity, concentrated in the Sahel, South Asia, and the Horn of Africa, precisely the agricultural zones most sensitive to monsoon failure. The 4.2 kiloyear event reduced three civilizations from urban complexity to scattered rural subsistence in under a century. The pace of collapse, not the fact of it, is what modern risk modeling consistently fails to incorporate. Number 3, the Cascadia megathrust. On the night of January 26, 1700, a tsunami struck the Pacific coast of Japan with no preceding earthquake. Historical records from multiple Japanese coastal villages describe waves arriving without warning, destroying fishing communities along the Sanriku and Kuril coastlines. An orphan tsunami generated by a seismic event too distant for its ground motion to reach Japan before the wave did. In 1996, researchers K. Satake, B.F. Atwater, and colleagues published findings in Nature that traced the source of the 1700 orphan tsunami to the Cascadia subduction zone, off the coast of what is now Oregon and Washington state. Using the wave's travel time and the distribution of damage in the Japanese historical record, they calculated the generating earthquake at magnitude 9, 0, or greater. The Cascadia subduction zone is a 1,000-kilometer fault system where the Juan de Fuca tectonic plate is diving beneath North America at approximately 40 millimeters per year. The fault is fully locked. The two plates are not sliding gradually past each other, but are coupled together, accumulating elastic strain with every passing year. The geological record read from ghost forests of drowned coastal trees, datable by dendrochronology, from submarine turbidite sequences on the seafloor, and from buried soil horizons in Oregon and Washington coastal wetlands, shows that the Cascadia fault has produced full margin ruptures 41 times in the past 10,000 years. The average recurrence interval is approximately 243 years. The last full rupture was in 1700. It has now been 326 years. Brian Atwater of the U.S. Geological Survey, whose work on buried soil layers established much of the fault's rupture history, has stated that Cascadia is statistically overdue for its next full margin event. A full Cascadia rupture would release energy equivalent to 32,000 Hiroshima bombs over 3 to 5 minutes of continuous ground shaking across a 1,000-kilometer coastline. The resulting tsunami would reach the Oregon and Washington coasts in 15 to 30 minutes. Here's where the modern parallel becomes exact. We know what Cascadia does because it has already done it, 41 times in 10,000 years. We know the wave heights because the 1700 tsunami's behavior in Japan allowed Sadake and colleagues to work backward and calculate the rupture geometry precisely. We know the inundation zone because USGS and Oregon Department of Geology have mapped it to street level. The prehistoric record and the modern hazard maps are the same document written in two different languages. Native oral histories from the Huayat, Maka, Quilote, and Yurok peoples describe catastrophic shaking and flooding events consistent with Cascadia ruptures. Accounts of villages swept away overnight and landscapes that shook until they fell, preserved across generations in the absence of written record. The 1700 event was experienced by living communities along the entire Pacific Northwest coast. Their oral traditions survived. Their coastal settlements did not. Approximately 1 million people currently live within the mapped Cascadia inundation zone. FEMA's 2013 Cascadia Rising planning exercise, the most comprehensive pre-event assessment ever conducted, projected that a full margin rupture would produce the largest natural disaster in United States history. The fault is locked. The strain has been accumulating since 1700. The geological clock does not pause. Number 2, the Toba catastrophe. In 1998, anthropologist Stanley Ambrose at the University of Illinois published a paper in the Journal of Human Evolution proposing that a genetic bottleneck detectable in the mitochondrial DNA of all living humans, a narrowing of genetic diversity far more extreme than the diversity of a single chimpanzee community in West Africa, was caused by a specific geological event, the eruption of the Toba supervolcano in Sumatra, approximately 74,000 years ago. He was not the first to identify the bottleneck. He was the first to identify what caused it. The Toba eruption is the largest known volcanic event of the past 2 million years. It expelled an estimated 2,800 cubic kilometers of volcanic material, or 100 times the volume of the 1980 Mount St. Helens eruption, 28 times the volume of the 1991 Pinatubo event. The ash deposits blanketed an area from the South China Sea to the Arabian Sea. In cores from the Bay of Bengal, Toba tephra layers reach 35 centimeters in thickness. Sulfur dioxide injected into the stratosphere converted to sulfate aerosols that reflected incoming solar radiation globally. Greenland ice cores show a sharp sulfate spike at 74,000 BP, followed by an estimated 3 to 5 degrees Celsius drop in global average temperature, lasting 6 to 10 years. Ambrose's bottleneck hypothesis, refined by Lynn Jord and colleagues at the University of Utah in a 2001 study, suggests the global human population was reduced to between 3,000 and 10,000 breeding individuals, a number smaller than the current population of most mid-sized American towns. Every person alive on Earth today is the descendant of whoever survived that decade. The Toba eruption expelled enough material to bury the continental United States under 9 centimeters of ash. The resulting volcanic winter brought the human species to the edge of a biological threshold it has never approached since. Here's where the modern parallel becomes genuinely disturbing. The Toba caldera, 100 kilometers long, 30 kilometers wide, now filled by Lake Toba in northern Sumatra, has not ceased volcanic activity. Samosir Island, which has risen 450 meters from the lake floor since the eruption, is direct evidence of ongoing magmatic uplift beneath the caldera. But the more immediate parallel is not Toba itself. In 2012, the Istituto Nazionale di Geofisica e Vulcanologia in Naples confirmed that Campi Flegrei, the caldera underlying the western suburbs of Naples, was in a state of accelerating bradycism, measurable ground uplift caused by magmatic injection from below. By 2023, ground deformation at Campi Flegrei had reached its highest recorded rate since systematic monitoring began in 1950. The caldera's last major eruption in 1538 was a minor event by the standards of its geological history. Its eruption 39,000 years ago is associated by paleoanthropologists with a population collapse among European Neanderthal communities immediately preceding their final extinction. If Ambrose's bottleneck hypothesis is correct, and it has been supported by multiple independent genetic analyses conducted across the following 25 years, then a single volcanic eruption 74,000 years ago brought the human species within a survivable margin of permanent biological erasure. The genetic diversity of all 8 billion people alive today is narrower than what exists within a single chimpanzee troop. We are not a species that narrowly survived an extinction event. We are a species that barely qualifies as genetically diverse enough to have avoided one. Campi Flegrei underlies a metropolitan population of approximately 500,000 people in Pozzuoli and western Naples, with a further 3 million in the broader Naples metropolitan area within the potential hazard zone. The Italian Civil Protection Department has established 4 alert levels for the system. As of 2024, Campi Flegrei remained at yellow, the second of 4 levels, with ongoing monitoring of ground deformation, seismicity, and gas emissions. The last time ground deformation at Campi Flegrei accelerated at rates comparable to current measurements was in the 1980s, when bradyseism episodes forced the evacuation of 40,000 people from Pozzuoli. That episode ended without a major eruption. The magmatic system has not stabilized since. Number 1, the 8.2 kiloyear event. In 2018, a team led by Neve Cahill at Maynooth University, using a statistical framework applied to sediment proxy records from across the North Atlantic, published findings in Nature Geoscience showing that the Atlantic meridional overturning circulation, the system of ocean currents that transfers heat from the tropics to the North Atlantic, moderating European climate, and driving global precipitation patterns, had been weakening continuously since the mid-20th century and was currently at its weakest measured point in at least 1,600 years. In the same year, Caesar et al. Published corroborating findings in Nature using sea surface temperature records. In 2021, Nicholas Boers at the Potsdam Institute for Climate Impact Research published a separate analysis in Nature Climate Change identifying statistical early warning signals in AMOC proxy data, increasing variance, increasing autocorrelation, characteristic of a dynamical system approaching a critical transition threshold. A tipping point, the threshold beyond which the circulation could reorganize into a fundamentally weaker, stable state and not recover on any timescale relevant to human civilization. The researchers were describing a mechanism that had already been triggered once in the post-Ice Age record. The result was called the 8.2 kiloyear event. At approximately 6,200 BC, the Laurentide ice sheet, the remnant glacial mass covering much of northern Canada, entered its final phase of collapse. As it melted, it filled a series of proglacial lakes, the largest of which, Lake Agassiz and Lake Ojibwe combined, held more freshwater than all 5 modern Great Lakes at their combined maximum. Between approximately 8,250 and 8,090 years BP, the ice dam retaining this system failed. An estimated 163,000 cubic kilometers of cold, fresh meltwater drained into the Labrador Sea and Hudson Strait over a period of weeks to months. The freshwater pulse disrupted the salinity gradient that drives AMOC. Cold, dense saltwater sinking in the North Atlantic, the mechanism that powers the circulation, was overwhelmed by a freshwater lid. AMOC slowed dramatically. Global temperatures dropped by 1 to 3 degrees Celsius within a decade. The cold event lasted approximately 160 years. Western European temperatures fell by 3 to 8 degrees Celsius. Monsoon rainfall across Asia and Africa collapsed. Neolithic farming communities across northern Europe, the Near East, and the Indian subcontinent abandoned settlements and contracted into survival mode rural clusters. At Abu Huraira in Syria, one of the earliest and largest farming villages in the archaeological record, the community left and did not return for a century. The sediment record from dozens of sites across 3 continents shows the same occupational gap. Not a gradual decline, a sudden stop. The freshwater pulse that triggered the 8.2 kiloyear event was equivalent to filling and draining the Black Sea 3 times in a matter of months. It dropped the temperature of the North Atlantic enough to collapse agricultural civilization across 3 continents for 160 years. But here's where the standard dismissal falls apart. The 8.2 kiloyear event required one discrete trigger, the catastrophic drainage of a specific ice dam lake system. There are no remaining Laurentide ice dams. That particular trigger is gone. What is not gone is the mechanism. AMOC runs on a salinity density gradient. Freshwater disrupts that gradient. The Greenland ice sheet is currently losing approximately 280 billion metric tons of freshwater per year every year, discharging directly into the North Atlantic at the precise location that is most sensitive to freshwater forcing. The Cahill and Caesar studies from 2018 show AMOC has weakened by approximately 15% since the mid-20th century. Bohr's 2021 analysis identified early warning signals in the proxy data that match the statistical fingerprint of a system approaching a bifurcation. The same class of transition that produced the 8.2 kiloyear event, but driven not by a single catastrophic drainage pulse, but by continuous, accelerating freshwater input with no endpoint in sight. The 8.2 kiloyear event lasted 160 years. It collapsed Neolithic farming communities from Syria to Scandinavia. It disrupted monsoon systems feeding populations across West Africa and South Asia. It is the fastest onset, most geographically comprehensive climate disruption in the post-Ice Age record, and it was triggered by a one-time freshwater pulse. The Greenland melt rate is not a one-time event. It is an annual discharge that has been increasing for decades, and it has no natural terminus until the ice is gone. The populations whose settlements the 8.2 kiloyear event erased had no understanding of what was happening to them. They had no ocean circulation models. They had no satellite altimetry data. They had no measurements of the salinity gradient shifting beneath the North Atlantic. They only knew that the harvest had failed, that the winters had lengthened, and that the world they had built was dissolving around them, faster than they could explain it. We know what is happening. We have been measuring it since the 1950s. The question the 8.2 kiloyear event forces is not whether AMOC will continue to weaken. Caesar, Cahill, and Bohr's have answered that. The question is how far, and whether the distance between the current trajectory and the reorganization threshold is measured in decades or in centuries. The proxy record from 6,200 BC is the only controlled experiment we have, and every year of Greenland melt narrows the gap between what we are measuring now and the conditions that produced it. If you want to see more videos like this, click the video on screen now and make sure to subscribe.